was a major achievement. A successful supersonic fighter gave MiG the platform from which to take the next evolutionary step towards Mach 2, twice the speed of sound.
Discovery Channel.
In July 1959, U.S. Vice President Richard Nixon visited Moscow and opened the American National Exhibition. In September, Nikita Khrushchev, now Soviet Premier as well as Party Secretary, arrived in the USA. His flamboyant behavior and range of moods impressed Americans and gave some hope that the Cold War might be thawing. But the hardware of the Cold War was well established. The American B-47 bomber had been in production since 1950. The larger intercontinental B-52 had entered service in 1954. Both could carry nuclear weapons, and both were seen by the Soviet Union as a threat. In 1953, the Soviet Air Force issued a requirement partly designed to counter this threat. It was for a fighter that could fly at twice the speed of sound and reach an altitude of almost 66,000 feet. It was to be smaller and lighter than the MiG-19 and capable of operating as an interceptor and as a tactical fighter. Airflow studies were carried out on 3 separate wing planforms, theoretically capable of performing at Mach 2. One was an ultra-thin straight-winged arrangement. Another was severely swept like the MiG-19. The third was a delta planform with swept leading and straight trailing edges. At the same time, the Lockheed Company in America was using the ultra-thin straight wings on its Mach 2 capable F-104 Starfighter. In France, the Dassault company was developing a Mach 2 interceptor, the Mirage, a pure tailless delta. Past experience was a major factor in the MiG design process. MiG was also very much under the influence of aerodynamic theory developed at the Central Aerodynamics and Hydrodynamics Institute, TSAGI. TSAGI had discovered that delta-type wings produce much less drag than swept or straight wings. Generally, the thinner the wing relative to its width, the less drag it produces. Delta wings are very wide at the fuselage, and so their relative thinness is greater than any other wing form. Russians call the pure delta wing the balalaika, because it's shaped like the famous Russian musical instrument. TSAGI's tests show that a pure balalaika planform would not give the runway performance required by the Soviet authorities. They suggested a compromise, a delta wing supplemented by a separate tail. This compromise would also help the aircraft meet other aspects of the requirement. It must fly conventionally and be maneuverable. MiG and TSAGI did not adopt the delta-tail combination without some assurance. They also developed a prototype with swept wings. In 1955, the swept wing version, the E-2, was fitted with a rocket engine in the base of the fin. The jet engine capable of pushing the prototype to Mach 2 was not yet ready. The E-50, as this version was called, performed well, but the first prototype crashed early in the test program. A second version was prepared. It had control and stability problems at subsonic speeds, which took some time to cure. By June 1957, the problems were fixed, and the aircraft was cleared to explore its performance capabilities. Various forms of the swept wing and delta wing prototypes were tested against each other for 3 years. Artyom Mikoyan came to the conclusion that the delta-tail combination had more promise. Experience with the MiG-15 and 17 had demonstrated the virtue of an engine installed in the fuselage with a nose intake. But they were both subsonic aircraft, and as speed increases, the cross-section of the normal nose intake cannot accept the increased airflow. A phenomenon called air intake stall occurs. On early prototypes, a fixed inlet spike was installed to smooth airflow, but as speeds increased beyond Mach 2, it became ineffective. The spike was made adjustable, and that provided the solution to the problem. The spike interacts with the airstream, smoothing the airflow over a wide speed range. The cone system was tested in Itsagi wind tunnel, and as part of the flight test program, it contributed greatly to the high performance of the aircraft that became the MiG-21. The control system was also modified. Originally, the primary control system had been hydraulic and the emergency backup system electrical. But the electrical system had a completely different feel and was a problem to pilots. It was replaced by a second hydraulic system with identical characteristics. By the end of 1958, the first operational MiG-21, the 21F, was ready for service. A batch of 30 aircraft was delivered to operational squadrons. The performance of the MiG-21F was so outstanding that for the first time the Soviets decided to claim official world speed records. The balance between secrecy and propaganda value tipped away from secrecy for the first time. On October the 1st, 1959, MiG Bureau test pilot Georgy Mosolov set the first Soviet official world speed record over a 25-kilometer closed course. The average speed was 2,388 kilometers, almost 1,500 miles an hour. But in spite of this new Soviet openness in claiming the record, the aircraft was given a false name. It was called the E-66. The Tumansky R-11F engine was officially registered as the R-37F. The airport used, actually, Zhukovsky, was registered as Podmoskovnaya Airport, which was not really a lie since it means near Moscow. The major goal of Soviet fighter development in the late 50s and early 60s was to reach higher speeds and higher altitudes. The primary emphasis was on all-weather interception of incoming threats rather than confined dogfighting. This meant that canopy visibility in early MiG-21s was not as important as it became later. The basic MiG-21 was modified into many different versions. One of the most obvious differences in outline between models is the shape of the dorsal fairing. It tended to grow as the aircraft developed, housing more equipment and fuel and raising the weight of the aircraft. Like all Soviet fighters, the 21 was designed to use rough, unmade airfields. The landing gear was tough and the wheels were large. The Soviet Air Force required the aircraft to be equipped with air-to-air missiles. Soviet copies of the American Sidewinder were available with the Soviet designation R-3S. They provided fire-and-forget capability. Confidence in these missiles was so high that MiG-21s of the early 1960s did not have any cannon. When it became clear that infrared homing missiles could be fooled by countermeasures and were not completely reliable, cannon were reinstalled as a backup. Two major families of MiG-21 developed, distinguished by the fact that in one the cockpit canopy was hinged in front and the canopy became an aerodynamic